Hey everybody, by the end of this video you should be able to define and apply accuracy and precision to either pictures or a group of numbers. In order for us to begin this though, we better define what accuracy and precision are. Accuracy is how close to the actual answer you are. So what I always remember is that accuracy is how close to the actual answer. So accuracy, actual answer, like AAA, okay? And then precision is a little bit different because it's how tightly grouped the numbers are, how close the numbers that you have are to each other. So closeness of and I will say the data, okay? So now that we have the definitions, let's talk a little bit about this. Let's say that we have a group of numbers. Let's say that as a class, you and your classmates measured something individually. The length of, let's say, a student desk, okay? And every one of you measured the student desk. So you had something like, however many students are in your class, 18 or 20 different numbers representing the length or the width or the measurement of that student desk. Now, if all of those values are close to the actual answer, that means that those values are accurate. Okay? Now, if all of those 18 or 20 measured values are close to each other, that means that they are also precise. Okay? Those two things are two totally different things because all the numbers could be very close to each other, but not close to the actual answer. So I have some examples here. We'll go over them. Okay, so here's a target. A lot of times, for some reason, people will show a target to talk about precision and accuracy. Okay, well, in this case, what we want to make sure we do is, if we're shooting an arrow, we want to get it inside the bullseye. So this yellow area, okay, is considered the bullseye. There are different zones in the bullseye. I guess the super good one is that one in the middle. Okay, but what I'm going to do is I'm going to represent you shooting an arrow with a green X. Okay, so you shoot an arrow and it goes whap, bing. Okay, and you hit it here. And then you shoot another arrow and it goes here. And you shoot another arrow and it's here. And you shoot another arrow and it hits right here. So you have 1, 2, 3, 4 arrow shots all around the same place. Where were we trying to hit it? We were trying to hit it in the middle, but we didn't get there. Okay, so we are not accurate. But are they all precise? Yeah, they are precise because they're all grouped together around the same spot. So now let's do another example. Again, green arrow, you're shooting your bow, an arrow at this target. Okay, so now what we do is we hit here, 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 and way out here. Okay, well, we have one answer one shot that's kind of close to the middle, but that's not really. The other three are spread out all over the place. So I think we are not accurate here, and I also think that we are not precise. We're not close to the middle, so we're not accurate, and the shots are all spread out, so we're not precise. So I'm going to take this again, and I'm going to erase all these. Now let's do it again, okay? It's starting to feel like Robin Hood. Okay, so now we're going to hit here, 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 here. Okay? So in this case, I think that here we hit right in the middle a whole bunch of times. So we hit where we wanted to hit. We were accurate. We got the right answer. We got in the yellow. And we were precise. All of those things are grouped together. Okay? So that's really good. And in science, that's what you want to do. You want to be accurate and precise. You want all your numbers to be close to the actual answer, and you want all your numbers to be close to each other. If one or the other or both of those things doesn't happen, typically you'll have to go back and change and re-experiment. Okay. Now, the only other thing that I do want to tell you is that in order for you to assess accuracy, you need to have an actual answer. Okay. So let's do some other examples with numbers. Okay. So in class, you guys are all asked to determine how old I am. Okay. And just for argument's sake, let's say that I am actually 39. And so this is 2015. I am actually 39 right now. Okay, and so that's the actual answer. Okay, so I open up and I look at the data you gave me, and here's a list of the data. Okay, somebody said I was 39, 38, 42, 39, 40, 37, 38, 36, 40. Okay, so are all of those answers accurate? Are they close? They don't have to be right on, but are they close to the actual answers? Well, yeah. Okay, so there's this one here is right on. This one's only 1 away and 3 away. Right on, 1 away, 2 away, 1 away, 1 away. This person just wanted extra credit, so they said that I was only 36 years old. No, but I mean that's still only 3 away. So I would say that most of those answers, if not all of them, are definitely accurate. Pretty good. Now, are they precise? Are they all close to each other? I would say so. If they're all like here, let's see, the highest number is 42 and the lowest number is 36. So they're 6 away from each other. I think that that's probably pretty good. So I would say, okay, that these numbers are accurate and they are precise. Okay. So now you guys were asked to guess how much I weigh. Okay. Well, here's all the... Whoa. Let me get rid of that because you don't need that. Okay. You guys were asked how much I weigh, and these were all the answers I gave you. Or not that I gave you, that you gave me. Okay. And so weight is a little bit harder to guess. Some people are a little more protective of their weight. And so if you look, all of these answers, look, 340 pounds, 195 pounds, 180 pounds. These numbers vary all over the place. So these numbers are not precise at all. Okay. Now, why could they not be precise? Well, it all has to do with how you came up with the number. Okay. I mean, it could have been that you were just eyeing me and looking at me and saying, you weigh about this. Maybe you all used different scales. Maybe some scales were sent to kilograms and not to pounds. And, there's a bunch of different reasons. But what we do know is that all of those numbers are not precise. They're not close to each other. Now, are they accurate? Well, we don't have an actual answer. So if we don't have an actual answer, here's what I'm going to tell you is you cannot determine, if you do not have an actual answer, you cannot determine if it's accurate or not. That is the way it works. So since there's no actual answer right now, you would say, well, accuracy cannot be determined. That's what it would look like. You would say accuracy cannot be determined. And what if I asked you why? Well, because there's no actual answer given. Okay. So now, the last set of numbers that I have are this. I asked you the question, how far away do I live from the high school? And you all come back with a list of numbers that looks like this, okay? And this is numbers in miles, okay? So you look and you're like, hey, 1.8, 2.2, 1.5, 1.1, 2.3, 2.1. Look, all of these numbers seem to be pretty close to each other, okay? They are close to each other. So if they're close to each other, what are they? They are precise, okay? Now, I give you the actual answer. Believe it or not, I do not live close to Collingswood. I actually live far away. So the actual answer is that I live 17.4 miles away. Okay. So are you actually close? No. Everybody's far away. So these values are not accurate. Not accurate. Okay. Yeah, they are all precise. Everybody had some idea that they thought that I lived very close to the high school, but I don't. And so whatever that the numbers were not precise, or were precise because they were all close together. And so you can come up with some reasons why they are precise, but they're not accurate. And the reason why they're not accurate is because they're far away from the actual answer. Okay, so hopefully you'll be able to determine some accuracy and precision because of this video. Have a great day.